Okay, this video is on the absolute value function, and you're probably familiar with taking the absolute value of a number, which just takes any number and it essentially makes it positive. And the absolute value function looks like this: y equals absolute value of x. And in fact, this is what we call the parent function. That's the parent function of the absolute value function. And we're going to graph this function over here on this set of axes. And the absolute value function looks kind of like a V. And the two sides of the V, it turns out this side here, which you can draw maybe a little bit more accurately on your sheet because you have kind of a little grid there. This side of the V has a slope of 1. And this side of the V has a slope of -1, and we're going to see a little bit later, why that happens to be notable. So this is a sketch of the graph of the absolute value parent function. And there are a couple things we want to note about this graph. One is the vertex, and the absolute value function has a vertex very much like the quadratic function has a vertex, and the vertex of the absolute value function is this point right there, that lowest point on the graph. And there's also something called the axis of symmetry, which we talked about also with a parabola. The axis of symmetry is just a line that divides a function into two mirror images. And so the axis of symmetry for the absolute value function would just be this line right here, which happens to be right on the y-axis. And you can see this line right here, it's the axis of symmetry. That line divides the graph of the function into two mirror images. Okay? So let's take a look at some transformations that we're going to do on the absolute value function. Now, these are the same transformations that we've been doing on our other functions, and we're going to use this form of the this form of the absolute value function. And the negative sign here in front, and we've seen this before, that negative sign causes a vertical reflection. That is, anytime you've got an absolute value function, it's got a negative sign, here outside of the function, that causes the graph to reflect vertically. This value here, A, the value in front of the absolute value bars there, that value A, it causes a vertical stretch if A is greater than 1, or it causes a vertical compression if A is, I'm going to write it like this, if A is between 0 and 1. If A is greater than 0 and less than 1. In other words, if A is a fractional value, it causes what we call a vertical compression. This value here, again, it's very similar to that value when we looked at the quadratic function. This value here that's inside the brackets, kind of inside the parentheses, if you want to think of it that way, this value here causes the graph to translate left or right. So this causes the graph to translate left or right. And then this value here, which is kind of outside of the, not the parentheses, but outside of those vertical bars, this causes the graph to translate up or down. All right, and again, each one of these types of transformations, and the part of the function that makes these transformations happen, these are exactly the same as we've seen in the other functions that we've looked at. All right, so let's take a look at how we're going to use this on a couple of examples. Okay, example number 1, identify the transformations. Okay, so for each one of these, all I want to do is I can see that each one of these is a particular it's a particular function using the absolute value parent function. And I just want to note, well, what are the transformations that have been done on the parent function? Well, so I just look at each one of these. I can see here my A value is 3, which means I've got a vertical stretch of 3. That's what that does. I can see this is, let's see, plus 2. That means it's going to move to the left 2. So that translates left 2. And this, minus 3 outside, means I'm going to translate down 3. All right, let's take a look at each one of the rest of these. So this one here, let's see if that's going to be right. 1. This one's going to be up 2. This one here, let's see. Vertical stretch of 2. Let's see, this is going to be left 3 and down 1. And let's see, this one here we've got several. This negative right here is going to give me a vertical reflection. The 1/3 is going to give me a vertical compression. Let's see, the minus 2, that's going to make my graph go to the right 2. And the plus 1, it's going to be up 1. All right? Let's take a look at this example number 2 here. Example number 2 says graph y equals the absolute value of x, which is the parent function. So let me graph that over here. All right, so here's my graph of the parent function. Now it says graph this function, which I can see is just my parent function with some different transformations. And in fact, in particular, I'm going to have a vertical reflection. Let's see, I'm going to have a vertical stretch of 2. I'm going to have a, let's see, a translation left 3. And then I'm going to have a translation up 2. All right, so let me apply each of these transformations here. So let's see, my left 3 and up 2 is going to put my new vertex. Let's see, left 3, up 2, new vertex about right here. And let's see, my reflection means it's going to turn it upside down. And then my stretch means that it's going to be stretched by 2, so I'm going to have a skinnier graph. So let's see. So it's going to be something like this. Left 3, up 2, reflected, and then a vertical stretch of 2. Now, as we're going to see in just a minute, it turns out that I can actually tell something, I can actually graph this a little bit more accurately than just saying, well, make this graph skinnier or make it wider. Because this number right here, it actually gives me a little more information that I can use to graph this transformed function, the stretched part, a little bit more accurately. And I'm going to give you a minute to see if you can figure out how that is going to work in those next examples in your notes. So go ahead and try those on your own, and we'll take a look at those answers in just a minute.